going to go over your review book, your geological history review book, part A, B, and C, starting at page 296. Number 1, which of the following landscape features in New York State were most recently formed? All right, I need you thinking back to when we did weathering and erosion. The Finger Lakes were created from glaciers. Now, if you looked at your reference table, page 9, the advance and retreat of the last continental ice sheet. All right, it's going to be your most recent thing. That's all the way at the top of the important geological events in New York State. So the answer is 1, Finger Lakes. Number 2, trilobite fossils from different time periods show small changes in appearance. These observations suggest that the changes may be the result of, well, you guys talked about this in biology. It's either adapt or die, so they had to evolve. So evolutionary development is your answer. Number 3, from the study of fossils, what can be inferred about most species of plants and animals that have lived on Earth? Okay, if I go back to your reference table, every time you had a change in an era, you had mass extinction. Majority of your animals and plants are extinct. Number 4, an igneous rock contains 1/2 of its original amount of potassium-40. According to Earth Science reference tables, the age of the igneous rock is closest to. Now, if it has half of its original amount of potassium-40, that means it's had 1 half-life. I need to go back to your reference table, page 1, under radioactive decay data. Find potassium, it says 1.3 times 10 to the 9th. So 1.3 billion years. Number 5, Mesozoic rocks and fossils found in Australia will most likely match Mesozoic rocks found in. Now, I need you on your reference table, page 9. 8 and 9. I need to find Mesozoic. You're going to read over, and you're going to find that Australia is really close. Well, Australia is really close to Antarctica. So your answer is Antarctica. Number 6, which 2 gases were commonly outgassed from Earth's interior into the atmosphere around 4 billion years ago? 4 billion years ago, the Earth was molten. It was all volcanic eruptions, one after another. So what's going to be outgassed is your carbon dioxide and nitrogen. They are still given off by volcanic eruptions today. Number 7, geologists can use meteorite fragments to correlate different types of sedimentary rock thousands of kilometers apart because meteorite fragments, well, same thing. It's going to hit, and when it hits, it's going to go into millions of pieces. So it's going to spread over much of the Earth's surface. So number 7, we're going to go with number 2. Number 8, what event in the evolution of life around 540 million years ago became an extensive fossil record on Earth? So I need 540 million years ago. If I'm going there, I'm at the intersection, close to the intersection between Cambrian and Precambrian. So what's happening is I'm going from soft body organisms to hard body organisms. So your answer is going to be animals evolved hard parts. Number 9, trilobite fossils were originally discovered in Himalayan mountain bedrock. During which geological period would these organisms have lived? Alright, so I'm looking at first of all, I need you guys thinking trilobites. So if I'm looking at Neogene, it's all the way at the top, Neogene, my trilobites were extinct already. Alright, my trilobites were also extinct during the Cretaceous. They were also extinct during the Triassic. So my only option, Cambrian. Number 10. What is the geological age of the surface bedrock of most of the Allegheny Plateau landscape region in New York State? So I need you to find the Allegheny Plateau on page 2 of your reference table. All right, for us, it's known as the Southern Tier. So going from page 2, go down to page 3, dot, 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 is Devonian. Number 11, when did the Jurassic period end? So I'm coming, and I gotta look up Jurassic. All right, it started 200 million years ago, it ended 146 million years ago. According to the Earth Science Reference Table, which geological event is associated with Grenville orogeny? Orogeny means mountain building. So I need you back on your reference table. Page 9, if you look all the way at the bottom, you'll notice it says the metamorphism of rocks of the Adirondack Mountains. So question number 12 answers 1. Number 13, present-day corals live in warm, shallow ocean water. Which inference is best supported by the discovery of Ordovician-age corals in the surface bedrock of western New York State? If I only find the corals in warm, shallow ocean waters today, the assumption is that was true millions of years ago. So that means if I'm finding fossils in western New York was covered by warm, shallow seas during the Ordovician time. Number 14, unconformities is a buried erosional surface. Remember, we said it's a gap in the rock record. Something's missing. All right, that would be answer number 3. Part of the geological record has been destroyed. It's been uplifted, it's been eroded away. Then you have submergence where it goes down and it goes below the water, and then you deposit more rocks on, more sediments on top to form other rocks. Number 15, based on the studies of fossils found in the subsurface rocks near Buffalo, New York, scientists have inferred that the climate of this area during the Ordovician period was much warmer than the present-day climate. Which statement best explains this change in climate? So if I go to my reference table, I'm looking at Ordovician all the way over, and I am sliding over. Here's my Ordovician. If I'm looking at North America, remember North America is the continent that they've blackened in. If I look at it, we're closer to the equator. So if we're closer to the equator, we're going to be more tropical, or we're going to be warmer. So answer number 15 is 3. Part B, base your answers to questions 16 through 19 on the following diagrams. Columns A and B represent 2 widely separated areas of exposed bedrock. The symbols show the rock types and the location of the fossils found in the rock layers. The rock layers have not been overturned. So that means the oldest is on the bottom, youngest at the top, law of superposition. 16. State one method of correlating rock layers found in the exposed bedrock represented by column A with the rock layers found in exposed bedrock represented by column B. Well, they give you the hint already. They're giving you index fossils. So you're going to use index fossils. That's one way to correlate them. Number 17, an unconformity, a buried erosional surface, exists between 2 layers in the exposed bedrock represented by column A. Identify the location of the unconformity by drawing a thick, wavy line at the correct position on column A. So if I'm correlating them, I have shale that is Cambrian, shale with Cambrian, they're the same. Right above it, limestone, right above it, limestone. Shale, right above the limestone, shale, right above the limestone. Then I go into limestone, that's Devonian. All right, right in between these two, I have conglomerate. Don't have it there. So that means I must have either eroded away or not deposited it. So, you're gonna make your wavy line in between these 2 layers. Number 18, state the evidence that the limestone is the most resistant layer in the areas of exposed bedrock. If I'm looking at it, it sticks out the most. So it's got to be the most resistant. Number 19, state the oldest possible age in millions of years for the fossils in the siltstone layer. If I'm looking at the siltstone layer, it tells me that I'm Cambrian. So I need to go into your reference table. Cambrian, the oldest Cambrian can possibly be is 542 million years. So that's your answer. In what era and period of geological time were much of the present day coal deposits formed? So again, you're back to your reference table. I'm looking at extensive coal forming forest. I'm reading over, it's during the Pennsylvanian. All right, with that one, I also needed a error, which is going to be my Paleozoic. Number 21, what produced most of the oxygen presently found in the Earth's atmosphere? Again, I need to go back to your reference table. I am looking here. Oceanic oxygen enters the atmosphere. Well, where did the oceanic oxygen come from? Read down, oceanic oxygen produced by cyanobacteria. All right, so that's combining with iron, and that's going to give us rust or hematite there. So if I'm looking at it, you could say from the bacteria, or if you're looking also, you could talk about with now, present day, I know you guys are relating to biology, it's going on with plants. So you could say plants are the cyanobacteria or photosynthetic organisms. Number 22. How can divergence of the lithosphere plates affect evolution of life on a continent? Now, when we did plate tectonics, remember, the plates are shifting. If I'm shifting, I can move my plate into a different location and then get a different climate. With changing of your climate, your organism is going to have to either adapt or die. Number 23. Why do large masses of evaporate sedimentary rocks, rock salt and rock gypsum, exist in Silurian rocks in western New York State, but are not forming there today? Well, if I'm looking for my evaporates, they come from evaporation of ocean water. All right, Buffalo area is not having an ocean right now. So no longer is it covered by a warm, shallow sea or an ocean. Flipping the page. Number 24. What are two events associated with the impact of a comet or an asteroid with Earth that would cause a major extinction of life? That one, if I'm having a mass, if it's going to collide, a major impact, you're going to form all that as debris gets forced up into the air. All that debris forms a dust cloud that is going to cut off the amount of sunlight that actually can get to the Earth's surface to warm up the Earth. So that means your temperatures are going to drop. It also is going to cause the clouds to become acidic. So when you have rain, you're going to have acidic rain, which, as you guys already know from your presentations, will kill your plants. Number 25. Why did most of the iron that existed near Earth's surface around 4.5 billion years ago end up in the Earth's core? Iron is more dense, so the more, remember, back then Earth was molten. The more dense materials got sucked towards the core, the less dense materials got forced outwards. All right, that's like our hydrogen and helium got actually forced out of the Earth and got out into the atmosphere. All right, most dense gets pulled in, less dense gets forced outwards. Number 26. Compare the age of the Earth in our solar system. The age of the Earth in our solar system is on your reference table. Page 8, all the way at the bottom. So the age of Earth and our solar system is 4.6 billion or 4,600 million years old. As you'll find out in your astronomy notes that are coming soon to you, that the universe is thought to be 13.7, 13.8 billion years old. So if I'm looking at that one, our solar system is a lot younger than distant galaxies. Number 27, while exploring a stream, a student found a rock containing a trilobite fossil. Name the most likely type of rock that this student found. All right, remember, igneous, it's going to melt it, it's going to destroy it. Metamorphic, heat and pressure would destroy the fossil, so it's going to be in a sedimentary rock. Now, which of the sedimentary rocks, classic sedimentary rocks, your clay-sized particles or your shale is going to give you the best detail. The larger the particles, it's harder to fit in all those little crevices to get a really good image of your fossil. So you'd have sedimentary, if they want to get pickier, which is your best, you want to say it's going to be your shale. Number 28. If a rock contains a trilobite fossil, in what geologic era did the rock most likely form? Now, we already know from here that our trilobites are A, B, and C. And they became extinct at the end of the Permian. So if I'm looking what era, they are in the Paleozoic era. Part C. Base your answers questions 29 through 32 on the geological cross-section below. Radioactive decay dating indicates that the granite intrusion is 279 million years old. The vesicular basalt is 260 million years old. The rock layers have not been overturned. Oldest on the bottom, youngest on the top. 29. List the 6 rock units in order from the oldest to the youngest. So the first thing I'm going to have is the siltstone that's on the bottom. Right above it is going to be my limestone. Then I am going to have my granite, because if you're looking at your granite, you have this wavy line that crosses the limestone and the granite, so that means it's the same erosion. So silt, limestone, granite, erosion. Then I had my shale. I only have contact metamorphism on the shale, so the vesicular basalts is my next thing after the shale. And the last to occur is the sandstone. If the sandstone had the contact metamorphism on it, then the sandstone would have been there before, but it does not. So the basalt had to happen before the sandstone. So siltstone, limestone, granite, shale, basalt, sandstone is your answer. Number 30. During which geological time period did the shale layer form? Now in the reading it said the granite is 279 million years, and the basalt is 260 million years. And the shale is going to happen in between them. So I need 279, all right, to 260. So I'm in the Permian period. 31. The granite intrusion caused part of the limestone layer to undergo metamorphism. What metamorphic rock will most likely be found in the form of contact metamorphism? I need to go back to your rocks. Page 7, metamorphic. Again, remember, reading under the comments. If I'm reading on the comments, metamorphism of limestone or dolostone, marble. Remember, I told you, everything ties back. Number 32. Between which 2 rock layers in the diagram is there most likely unconformity? Well, I already talked to you about your wavy line. So your unconformity, you could say between your limestone and your shale, or you could say between your granite and your shale. Either one works. Number 33. Why can life as we presently know it exist on Earth and not on other planets in our solar system? Well, we evolved because of the pressure and the temperature that we have right now and the amount of free oxygen that's in the air. Other planets do not have that, so therefore we would not exist on other planets currently. 34. In natural exposed bedrock, how is it possible that a meter-wide piece of sandstone be found within an igneous rock such as granite? Now, that igneous rock or granite is going to melt and incorporate some of that sandstone. But as it moves further in, you're going to get some metamorphism on that. With sandstone, metamorphism of sandstone, if you go back to your reference table, page 7, you're going to get quartzite. It won't necessarily get all the way through. So you can have huge rocks of sandstone that are surrounded by quartzite, and then you have granite. All right, that would be called an inclusion. Read the following article about radon. Use your knowledge of earth science and the information in the article to answer the questions 35 through 38. Really important for you to read. Radon is a gas gained public attention in 1984 when a worker in Pennsylvania nuclear power plant was set off radiation alarms not when he left work, but when he entered. His clothing and hair were contaminated with radon decayed products. Investigations revealed that his basement at home had radon level 2,800 times the average level of indoor air. The home was located along a geological formation known as the Redding Prong, a mass uranium-bearing rock that runs from near Reading, Pennsylvania to near Trenton, New Jersey. Radon is continually generated by the gradual decay of uranium. Because uranium has a half-life of about 4.5 billion years, radon will be with us forever. Radon itself decays, having a half-life of only about 4 days. Its decay products, except lead-206, are all radioactive solids that adhere to dust particles, many of which we inhale. Steadily accumulating evidence indicates radon may be a significant cause of lung cancer, second only to smoking. 35. If the half-life of radon is only about 4 days, why does the Redding Prong, which has many millions of years old, still have produced radon gas? As I read earlier, that's because radon is a product of the gradual decay of uranium, and uranium's half-life is 4.5 billion years. 36. Radon is often most concentrated in basements. What does this suggest about the density of radon gas compared to that of air? If you go into the basement, it's there because it's more dense. So radon's got to be more dense than air itself. 37. Would radon be a suitable radioactive element to use in radioactive dating? Explain. All right, considering radon's half-life is only 4 days, it is too short of a half-life to be useful into dating things that are millions of years old, so no. 38. If you were a homeowner on Redding Prong, what might you do to ensure the lowest possible concentration of radon gas in your home? You'd want to make sure you seal your basement so there's no cracks, and you want to vent your basement if you do have any radon in it. Base your answers to questions 39 through 41 on the passage below. Fossils and the history of the Earth's rotation. Data from the coral fossils support the hypothesis that Earth's rotation rate has been slowing down by 2.5 seconds per 100,000 years. Scientists believe this is due to the frictional effects of ocean tides. This slowing rotation rate decreases the number of days in the year. Scientists have discovered that the corals produce a thin layer of shell every day, resulting in a growth ring. These daily layers are separated by yearly ridges. In the Devonian coral fossil, Pleurodictum, has approximately 400 growth rings between each yearly ridge, which suggests that there were about 400 days in a year during the Devonian period. Supporting this hypothesis, scientists have found coral from Pennsylvania period that have about 390 growth rings per year, while the present-day corals have about 365 growth rings per year. 39. Approximately how many fewer Earth days per year are there today than there were during the Devonian period? All right, to do a little math, 400 minus 365, your answer is 35. Number 40. What inference can be made about the number of growth rings per year for a coral from the Permian period and Ordovician periods compared to the number of growth rings per year for the Devonian coral Pleurodictum? So you guys would have to use your reference table. Page 8. You'd have to figure out what is younger. Is it going to be Devonian, Permian, or Ordovician, and where does that go? So if I'm looking at it, Ordovician is older than Devonian. Devonian is older than Permian. Knowing that, your answer is going to be Ordovician coral will have more, but Permian coral would have fewer. Number 41, the evidence of the fossil Pleurodictum found in the surface bedrock of the Finger Lake regions of New York State suggested this region was once, all right, it's a coral. You find coral in warm, shallow seas, so that the Finger Lakes was covered by a warm, shallow sea. Base your answers to questions 42 through 44 on the paragraph below, which provides background information regarding a recent fossil discoveries in Canada. I'm going to have you guys read this. I'm going to go right to the answers. Remember, some of the answers are in the reading. You need to read them. 42. According to the fossil evidence, during which geological period did the earliest mammals appear on Earth? Now, you got to go to your reference table. Nope, take it back. If I'm looking here, it says scientific evidence indicates that the earliest mammals may have evolved approximately 225 million years ago. So you got to go to your reference table. 225 years is in between 251 and 200 million years ago. So that's going to be during the Triassic period. All right, explain why Coreopsis proximus would not be a good index fossil. Now, if you read it, they only found that fossil in Calgary, Canada. So if it's only found in Calgary, Canada, I can't use it to correlate in other locations. So the whole idea, that would not be a good index fossil because it is limited to one location. It's not widespread. Number 44, state one method geologists could have used to determine Coreopsis proximus lived 60 million years ago. All right, the easiest one to do is radioactive decay dating. You also could see the fossils surrounding him or her. Above and below, you could use index fossils. Base your answers to question 45 through 46 on the cross-section below, which shows a widely spread outcrops location W, X, Y, and Z. The rock layers have not been overturned. Line A, B in the cross-section at location W represents an unconformity. Fossils are shown in some of the layers. This should look really familiar. This is your Lab 22. Flipping the page over, but you're going to have to use the diagram that's on the bottom. 45. Determine the relative geological age of the four fossils by correlating the rock layers between these outcrops. Number the fossils from 1 to 4 in the order of relative age. 1 being the oldest and 4 being the youngest. Okay, you are back to your reference table. First one I'm looking at is a trilobite. All right. Then, after my trilobite, I have a crinoid stem. Let me flip this over. Actually, I'm going to do it this way. All right. So, if I am going to connect it, let me grab a pen. You got to connect likes with like. All right, so if I'm looking at it, these two are the same. So that would push up. These two are the same. So that would push that up. And obviously, those two are the same. So if I'm looking, this one would slide up next to this one, and these would slide together, and this one's on top. Oldest is going to be my trilobite. It's all the way at the bottom. On top of the trilobite is my crinoid stem. All right, on top of the crinoid stem is my ammonite, and on top of my ammonite is my pecten. So I went to number them. Crinoid stem 2, trilobite 1, pecten 4, ammonite 3. Like I said, this is your Lab 22. Identify two of the processes involved in the formation of unconformity. Remember, unconformity is a gap in the rock record. Something's missing. Represented by line AB in the cross-section at location W. So if I go back to a location W, I have that wavy line because what I did was I brought this up, I uplifted it to the surface, I weathered it, I eroded it, I had it submerged back again, so it went underwater, then I deposited the sediments above. So any of those would work. Uplift, weathering, erosion, submergence, and deposition. Base your answers on questions 47 through 49 on the cross-section below and your knowledge of earth science. The cross-section shows a portion of the Earth's crust. The age in millions of years of each boundary between different sedimentary rock layers is shown. The age at boundary X between the sedimentary rock and the metamorphic rock is not shown. Assume no overturning has occurred. That means if no overturning has occurred, oldest on the bottom, progressively younger as you go up. 47. Identify the geological feature represented by the boundary X. So if I look at boundary X, it's that wavy line. Wavy line means there's an unconformity, a gap in the rock record, erosion. Number 48, describe how the rock type below boundary X was formed. It tells you it's metamorphic. If you can't remember how metamorphic rocks are formed, you're back to your reference table, page 6, rock cycle. To get a metamorphic rock, you have to add heat and or pressure. 49, identify by name one index fossil that existed when the limestone rock shown in the cross-section was being formed. If I look at your limestone, it tells you it's what? From 443 to 418 million years ago. I need to go to your reference table. Page 8 and 9. 444 to 418 is Silurian. So go straight through, and you are looking for a letter that occurs during the Silurian period. So letter E. Slide down, what is organism letter E? Come back. Letter H. What is organism letter H? Letter M. What is organism letter M? P. U. And Y. Any of those would work. You just need to make sure that the letter itself is in the same row as that period mentioned. Base your answers to questions 50 through 53 on the cross-section below, which shows a portion of the Earth's crust. Letters A through J represent rock units or geological structures. The rock units have not been overturned. So again, oldest on the bottom. Number 50. On the cross-section, draw a circle around the letter of the oldest rock unit. So if I'm looking, my oldest is going to be on the bottom, correct? So if I'm looking, it's either going to be my letter F or it's going to be my letter I. Now, seeing the contact metamorphism from F onto I know I, along with all these other layers, had to be there before F. So letter I is the one I'm going to circle. That is going to be my oldest. 51. On the same cross-section, place a X to indicate the location where the rock marble was formed. Now, going back to your reference table, we talked about this one earlier. Igneous metamorphic rocks. Marble. It's a metamorphism of limestone or dolostone. So you are going to look for where you have contact metamorphism along limestone. So if I notice, here's my limestone. So I would put any of my X's could be on this side where I have contact and limestone, or in this area where I have contact and limestone, or in this area where I have contact metamorphism and limestone. So you have a variety of places that you can put it. 52. Describe one piece of evidence shown in the cross-section that suggests rock unit D is younger than rock unit F. All right, if I look at D, D does not have any contact metamorphism on the bottom of it. So therefore, you had your igneous intrusion, you eroded, and then you had D. So the lack of contact metamorphism tells me D is younger than F. 53. Explain why rock unit H is not one continuous layer. So if I look at H over here, why is it offset? Well, it's offset because you have a fault going through it. All right, I hope this is helpful. Remember, you have a test this week. It's the first grade on the 6th marking period. Good luck. Questions, email me.